Guys, those who are online, what have they started in your school? Harish, Harini?
So continuity and differentiability.
Okay, Hamsini, yeah, that's what they told here. What about Harish?
Sir, integration, sir.
Sorry, integration.
Oh, yes, sir.
Okay, what about Harini? Yeah, what have they started in your school? No?
So relations and functions is over and they have now started investigation.
Okay. Okay. So okay, I thought I need to start with the third chapter, then I'll go with fifth then. So in none of the schools they have started. But all they start suddenly right in middle of something. I have recording I'll give you for the time being. You can go through them. Okay. So shall I shift on to this one, fifth chapter? For third and fourth are independent only. You can learn at any time. But relations and functions, inverse trigonometry and continuity and differentiability, we have to go in this order. So listen. So we'll move on to the next chapter, that is fifth one, continuity and differentiability. So if you ask me, right, you have learned this chapter last year also. Under what name? Limits and derivatives. Okay, I'll say that both the chapters are same. Correct. So now I have some questions. Okay, so it is not about limits here. You are using the word continuity. What is the meaning of this? So what do you mean by limit exists or not? So you would have learned something like this. Limit exists. So last year you would have had problems asking you to verify whether limit exists or not. What will you do? You will find left limit, the right hand limit, and that should be equal to. If that is equal to the function value, you can say that the limit is existing at the given point, whatever it is. C, x naught, whatever you call that as. Correct? Right. Now, how is this limit existing concept going to help us in the case of continuity? Why did I say both are same? So, if at all there is a possibility where limit is existing at a particular point, you can say that the given function is continuous. Let's see the meaning of it. Okay. Now, I have a graph like this. Okay. I have a function in this way. There, I'm taking a point C. Right. So, what is happening at point C? There is the breaking point, right? So generally the breaks are drawn with open circles. Okay, how do you draw it? With an open circle. Okay, having said this, now my question is, how will this is the one that graph is telling us, but how will you validate with the help of mathematical operations? How will you find out whether this is true or false with the help of mathematics? What will you do? You will find the left limit and you will find the right limit and you will equate it to the function value at that point. So tell me in this graph, what is the meaning of it? Left limit means what? What is the meaning of left limit? From the left-hand side of whom? From the left-hand side of this point C, you are approaching towards point C. Right? So can I say you are going in this way? Similarly, what does right limit mean? To the same point C, you are trying to approach from right-hand side. If those two come and meet at a particular point, they will give you the same value. If not, they'll give you different values. So the moment they give you different values, you in terms of limits, you are going to say that the limit does not exist. Whereas in terms of continuity, you are going to say it is not a continuous function. Are you able to understand this point? Okay. So this is all about continuity. Let's take an example. First, let's discuss with some examples. Then I'll give you some theory to understand. So let's say there is a function f of x is equal to 1 for x less than or equal to 0, meaning 0 and negative values of x, you have a constant function called as 1, and it is 2 for x greater than 0. Am I clear with this? Right. When you try to plot it graphically, what are you going to get? So x is equal to 1 is a line parallel to, y is equal to 1 is a line parallel to x-axis at a distance of 1 unit. Accepted? So this is x is equal to 1. But what is happening at 0? Is this function having 0 included in its domain or not? Yes. So when it has a 0, you're drawing a circle which is closed. Right? Can you tell me what is the meaning of this? Means you approach 0 from the left of it, right? Then the left limit is exactly equal to the function value. When can you find function value? Only when you have equal to sign. If you look at the domain, which one is having equal to sign? X less than or equal to 0 or x greater than 0? Equal to 0. So that one will give you the function value. So if somebody asks you in this question, what is f of 1? What will you say? 1. What is f of 2? Sorry, what is f of 0? I'm sorry. What is f of 0? 1. Okay. So this f of 0 is going to be 1. It is not 2. You're able to understand? So it cannot, the question cannot be in such a way that x is less than or equal to 0 and x is greater than or equal to 0. It will not happen unless those two values are the same. Okay, or else the function will be discontinuous. Let's try to understand it graphically. So what is happening here is this point clear? You're approaching from the left-hand side. Left limit is exactly equal to function value, but it is not equal to what is happening. So for x greater than 0 means y is equal to 2. So for y is equal to 2, you're up, it is a line parallel to x-axis, but where are you supposed to start from? You should start from the positive values of xy, because the domain says x greater than 0. So what is happening at 0 for this case? So at 0, it does not have a function value. That is why you're drawing an open circle to it. So what I'm trying to conclude from here is, even before you approach it mathematically, one important point to be known is, if the left limit is equal to function value, it is still a continuous function, but it has a special name called as left continuous function. Why? Because it is continuous from the left-hand side. That is the reason. Had the same question been in such a way that from the right-hand side, the right-hand limit is equal to the function value, you call it as a right continuous function. You're able to understand? But as a whole, is it continuous at point x is equal to 0? Why is it not continuous? Because left limit is leading to 1, function value is leading to 1, but the right limit is leading to 2. Did you understand what I meant by left limit is leading to 1? Hey guys, you know limits or not? Is there anyone who's not confident with it? Clear? You know the steps and all those things. That is what I'm going to do next. Clear? Okay. Anyways, when I'm going to discuss it, I'll tell you. So, are you clear with the basics of what do I mean by continuity? Right? In simple terms, yes, what you told is right. You're going to verify the limit, but graphically, this is what is going to happen. So, for you to understand this, you definitely need the basics of functions. Only then you will know whether it is a one-to-one function or the composition of function, because there will be a topic, I think 5.4 or the 5.50. They'll say it is a differentiation of composite functions. And the time look, you should not composite function and f of g of x. So there you use something called as chain rule. So you need to understand functions in the first place. Only then if you have grip over domains, then you will have better clarity. Is it clear, guys? Now look at this function. F of x is equal to 1 if x is not equal to 0, meaning so at any other point other than exact 0 value of x, the function is always 1. Whereas at f of whereas at x is equal to 0, what is the function value? 2. Now, when you try to plot it graphically, right? See, the first thing that I will do is I generally think in this way. So f of x is equal to 1 means what will you do? You will draw a line parallel to x-axis at a distance of 1 unit from the x-axis. Are they clear? But what are they trying to say? Now look at the domain. X is not equal to 0, no meaning another. So at 0, there is no value that is existing. We know what is going to function at x equal to 0. So at x is equal to 0, can I draw an open circle? Right. But at x is equal to 0, what is the next step telling me? The value is 2, meaning it is 0, 2. So tell me about this function. Left limit is equal to the right limit, but not equal to the function. Why am I saying left limit is equal to right limit? When you approach from left limit, you are reaching the point 1. When you approach from right hand side, you are reaching the same point 1. But exactly at 0, what is happening? You are reaching 2. So this kind of a function is again said to be a discontinuous function. Is that clear? Now, having said this, we need to define what exactly is a continuous function. Okay. So the definition says something like this: if f is a real function or real valued function. Okay. If f is a real function on subset of the real numbers, and let's say c is some point in the domain of it, then if limit extends to c is equal to f of c, then that is the required mathematical condition for you to prove that the given function is continuous. That is what they're trying to say. Okay, please write it down. So it's in page, what is the page number? 148. In page 148, there is definition number 1. Please make a note of it. Finish, guys? Okay. It is at 2 it is continuous. At 2 it is continuous because x is equal to 2, 0 means draw a line perpendicular to it. Okay. So is there any break in the graph? So it is continuous. So this function clearly tells you that the given function f of x is equal to 1 and 2 is continuous at every point in the real number system except 0, because that is the point where the function is broken into 2 different values. So most of the problem, this is what will happen. This is what happens. Okay. Because there will be some cases where you will be asked to find the point of discontinuity. So how will you know without the domain knowledge? Right. So shall we do some example and see? So check the continuity of the function f given by f of x is equal to 2x plus 3 at x is equal to 1. So read the question carefully. Okay? So what is it trying to say? Check the continuity of the function f given by f of x is equal to x plus 3 at x is equal to 1. What is this 2x plus 3 in the first place? It's a polynomial function, to put it in simple terms, right? So polynomial function, by default, what is the domain of it? For a polynomial function, what is the domain? It is real number, right? So we can say that f of x is equal to 2x plus 3 will exist for what? For all values of x that belongs to the real numbers. Out of those real numbers, what is the point at which we are asked to check the continuity of the function? 1, right? So what is the definition that you told you? For a real valued function f, if limit extends to c, in this place what is c? 1, f of x is how much? Limit extends to 1, 2x plus 3. Take this and substitute. This will be 2 plus 3. Answer will be 5. Then what is f of 1? F of 1 is 5. So limit extends to c, f of x is equal to f of c. Then if the both values are same, then you can say that the given function is continuous. Okay. So this is the step that they expect for continuity. But if you want to go slightly in depth, right, you can find the left limit and the right limit. How do we find the left limit and right limit? So I will do that and show you. Okay, you can just make a note of this. For left limit, right, you generally take the point limit extends to c minus on the top. What does that mean? So with that number, you're trying to check the value on the left of it. So when you say left of it, right, you take, if suppose the value is 1, what is the left value that you're trying to consider? It is 0. Let's say 100 9s put together. But there is still the difference that is existing. So if you try to find the difference between both, how much will be the value? Which will approximately be 0. So limit extends to c minus f of x can be written as limit. You shift that limit from extends to c minus to another variable h which tends to 0. And inside the function, you change it as c minus h. Do you remember this? How many of you remember? Right, what are we doing here? So limit extends to, it is something like substitution of extends to c minus. You're shifting the variable from x to some value h, where that h is tending to 0. What is the meaning of it? 1 minus 0.999999 is approximately 0 is what I'm trying to say. And what does that c minus h tell you? It is very simple. If I take this point to be c, then on the left of it, what will happen? I have the point c minus h, so that the difference between c and c minus h is how much? H, where that h value is very small. It is tending to 0. It is not exactly 0. That is why if you see calculus is approximation. Somebody asked you differentiation, you're finding, right? That value is an approximate value, which is closer to the accurate one. It is not accurate one. Okay, that is why you see it is always tending, not equal to. So f of c minus h means you're trying to find, sorry. So what will this be? So what will this point be, guys? This will be c comma f of c. And what will this point be? C minus h comma f of c minus h. Now what you're doing is you're finding the function value at f of c minus h, f of c minus h. Okay. In that you're trying to say h is tending to 0. When it is tending to 0, what will happen to c minus h and c? They will start overlapping. They will start to overlap, but they will not overlap. If you look in a microscope, there will be a small difference existing. Okay, this slightly needs higher order thinking, but this is actual meaning behind it. Is that clear? So having said this, if at all you have the function f of x is equal to 2x plus 3, at which point it asks you to check the limit? 1. So limit extends to 1 minus. If I say f of x, this can be written as limit h tends to 0, f of 1 minus h. Are you able to understand? So from here onward, you'll write limit h tends to 0, f of 1 minus h, now 2 into 1 minus h plus 3. Correct? So this will be limit h tends to 0, 2 minus 2h plus 3. Now substitute the limit. What will happen? H will be 0. So 5 minus 0 is going to give you 5. That is why the left limit is 5 in this. Am I clear, guys? In a similar way, can you tell me what will happen for right limit, and I want you to try. Only thing is, what difference will you make in the right limit? Limit extends to c plus. First step. C plus, when you write it, you should write f of x. Next step, another. Limit h tends to 0, f of c plus h is what you write, and then proceed. See if you are getting the same answer. You should get. So limit extends to c plus f of x, correct? What should be the next step? Limit h tends to 0, f of 1 plus h. Here 1, yeah, c plus, na, here I should write it as 1 plus. Correct? So this value will be equal to limit h tends to 0, 2 into 1 plus h plus 3. So it will be 5 plus 2h, where the limit h is still tending to 0. Now you substitute the limit, what will happen? It will still be 5. So left limit is equal to the right limit. And what is the function value? Obviously, it is 5. The left limit is equal to right limit is equal to function value. Okay. So every time you need not do these steps, because according to your 12th standard, they gave you the definition 1. Limit extends to c f of x is equal to f of c. If this is satisfied, that is enough for you to prove that the given function is continuous. So I hope this knowledge is enough, right? Now you can solve left limit and right limit also, right? Yeah, tell me.
Sir, when you are saying in terms of left limit and right limit, it's much easier. But like f of x is equal to f of c, like what should we prove there, sir? Like f of x is equal to
Nothing. You just substitute the limit and find it out. That's it. It's only one
sir,
step.
how it becomes continuous? Like what's the logic?
Because when you say limit extends to 1 f of x, right? You're getting a value, right? When you generally write extends to 1 f of x, you have covered left limit and right limit within itself.
Okay, sir.
That is the reason why we directly go with it. So that's why they gave you the definition directly. Okay, but one thing that I want you to master is understand the domain of the function and then proceed. Sharia. Example number 2. Examine whether the given function f of x is equal to x square. Again, x square is what? A polynomial function. Is continuous at x is equal to 0. Is it continuous or not? Yes, it is. So how will you do it? So what are the steps you will use to show? Limit extends to, no need of left limit and right limit, guys. Don't do that. Not needed. Limit extends to 0. That is the value of c. F of x. So do it separately. Limit extends to 0 means limit extends to 0. What is f of x, guys? X square. Substitute the limit, it will be 0. What is f of 0? 0. So since limit value is equal to the function value, you can say that the given function is continuous. So first 2 problems or 3 problems will be simple like this only. But once you go, you need to have clarity. Okay. Third one, discuss the continuity. So here, if you see, discuss the continuity of the function f of x is equal to mod x at x is equal to 0. So first is you need to know how to break this function. So how will you do this? First, we need to break it as f of x is equal to, I generally break it like this, okay? X when x is greater than 0, 0 when x is equal to 0, minus x when x is less than 0. Okay, so in this case, I have no other option other than going with the left limit and right limit. Why? Because the function is broken at the same point. Which point is it broken? 0, right? And they're unfortunately asking us to check the continuity at 0. So you have to find the left limit and right limit. So limit extends to 0 minus. So limit extends to 0 minus means what do I have? F of x is equal to, what will be the next step? limit h tends to 0. Okay, limit h tends to 0, f of 0 minus h. Right. So limit h tends to 0, f of 0 minus h. Now, what function should I use? Should I use minus x or 0? So 0 minus another on the left of 0. On the left of 0, what function is defined? Minus x. So I need to use minus of 0 minus h. Accepted? So once I substitute this limit, it is anyway going to give me a 0. See, even without solving, you can tell that, but you need to show those steps. Are you able to understand it? So please do it. So similarly, how will you calculate the right limit? Limit x tends to 0 plus and then solve it. So right limit, I hope you guys found it. So how will you solve? Limit x tends to 0 plus f of x. Next step, limit h tends to 0, f of 0 plus h. Correct? So limit h tends to 0. 0 plus now, what function will you choose? X is greater than 0 now? It is x. So it is 0 plus h. Now substitute the limit again. It is going to be 0. Correct? I hope it is clear, guys. And function value f of 0 is how much? That is 0. So since all the three are same, it is a continuous function. So if you actually look at the graph of mod x, right, it looks something like this. X greater than 0, it is like this. Y is equal to x. So this angle will be 45 degrees. Y is equal to minus x is something like this, which will be 135 degrees. And x is equal to 0 is this. There is a point of x is equal to 0. So it takes the shape of a V. Okay. So that how much is this angle, guys? This will be 135 degrees. And now y is equal to minus x. Slope is minus 1. Correct? So that's the answer. So if you want, just make a note of the graph as well. This is Ravia. Range of the function is 0 to infinity. Range in the y direction. So minimum value that you're going to get is 0. And where is this line getting extended to? Infinity. So the range is going to be 0 to infinity, whereas 0 closed 0 to infinity, whereas the domain will be, what is the domain of this function, guys? All real numbers. That is minus infinity to plus infinity. There is a domain, there is a range. Okay. So show that the function f given by f of x is equal to x cube plus 3 for all values of x not equal to 0 and 1 for x is equal to 0 is not continuous at x is equal to 0. What will you do? So check the limit at x equal to 0. What is the limit at x is equal to 0? Limit x tends to 0, x square plus 3, that is going to be 3. Okay, x cube plus 3, that is going to be 3. Then what is f of 0? 1. So according to the definition, the limit x tends to c f of x is not equal to f of c. Hence it is not continuous. Can we go a little faster? Done? Now see, example number 5. Check whether the constant function f of x is equal to k is continuous. So for a constant function, what is the domain? All real numbers. So in all the real numbers, let us consider a point C. So what we will do is let us consider a point C where we will try to check the limit. Limit extends to C. F of x is how much? Limit extends to C. F of C is k. How much is the value? It is k only, because there is no x on the other side, so you cannot substitute anything. It is k. What is f of c? That is also k, because it's a constant function. Whether you substitute c1, c2, c3, anything you are going to substitute, the value is the same. So the function is like this. So you take any point c in the real number system, it is going to be continuous from all the directions. That is the meaning of it. Is that clear? So example number 6. Prove that the identity function. So if they don't give you the function also, you should be knowing what is an identity function. F of x is equal to x is an identity function. So they are asking us to prove that this identity function is continuous for all real number. Again, what will you do whenever you have this kind of a problem? You should start the problem like this. Let C be a number which belongs to the domain of that function. What is the domain of the function? Which belongs to the real numbers. Limit extends to C, f of x is equal to limit extends to C, x. Correct? F of x is x. So when you substitute the value, it comes out to be C. What is f of C? C. So since limit value is equal to the function value, you can say that the given function is continuous for all the values in the domain. Okay. So that's the meaning. Done. So this is all about the problems that are based on definition number 1, guys. Okay. Let's go to the definition number 2. So in definition number 2, they're trying to say if you have a function f and if you want to call it as a continuous function by default. So there are two ways of defining it. If you see definition 1, what is the statement? A real valued function f is said to be continuous. Read the statement. It's said to be continuous. Okay. The function is said to be continuous at point C. Read the last statement. So the function f is continuous at C. So C is one of the points in the domain. But whereas definition number 2 is also speaking about continuity, but what difference are they bringing in? If at all you say a given function is continuous by default, if at all you pass a statement of this sort, then you are by default telling that this function is continuous at every point in its domain. That is the meaning of it. That is what I had been telling from the beginning. You need to be good with domain again. You're able to understand, guys? A real valued function f is said to be continuous. If you use that word continuous, if it is continuous at every point in the domain of f. So you can ask me, so to prove a given function to be continuous, do I need to check the continuity at every point? No. You can take one random point called C, which belongs to the domain set. And if you are able to prove that it is continuous at that given point, it is enough. Like how you did in the 6th problem. Is that clear? Now, shall we do a problem? So, is the function defined by f of x is equal to mod x a continuous function? Yes, it is. So, you know how to prove the continuity. We have already done the problem, 3rd problem. It's the same logic. Okay, it is continuous. 8th one. Discuss the continuity of the function f of x is equal to x cube plus x square minus 1. So when they ask you to discuss the continuity, first look for the domain. What kind of function is it? Obviously a polynomial. Domain is real number. So when I say domain is going to be real number, you need to take any point C in the domain, prove that limit extends to C is equal to f of C. That's enough. Do it, make it fast. Niranjan, Tarush, alla puriyada? Yeah. Sandhya, clear, right? Nitin? Guys, those who are online, you're clear, right? You're able to solve on your own? Very good. Please. It's simple, right? So what will you get? C cube plus C square minus 1. That is the limit value and the function value also. Hence, it is continuous. Generally, polynomial functions are continuous. Okay. This is where the challenge will start. Look at this function, 9th one. Discuss the continuity of the function f of x is equal to 1 by x. What kind of a function is this? It's a rational function. So numerator and denominator are polynomials. But what will be the domain of this function? All real numbers except 0. But when they say discuss the continuity of function, you need not take the point 0 because it's not a part of the domain. Right? So you will say let C be any real number which belongs to the real number set except 0, such that what happens for this limit extends to C f of x. How much is that, sir? Limit extends to C 1 by x is equal to 1 by C. What is f of C? 1 by C. It is continuous. So if you want to see the graph of f of x is equal to 1 by x, right, it looks something like this. This is the value. This is how the function looks. It's called as rectangular hyperbola. F of x is equal to 1 by x is generally called as rectangular hyperbola. Seriya? Oh, they gave the graph. See. This is the graph. Okay. So are we good to go with the other problems? Yes. Let's do it a little faster, no? Please. So 10th one, discuss the continuity of the function defined by. So if you look at the function, right, it is broken at a point. If you see x plus 2, what is it? Polynomial function. X minus 2 is a polynomial function. So for both the polynomial function, what is the domain? If you take them as individual functions, the domain is all real numbers, but it is broken in such a way that between the points minus infinity to 1. So between the points minus infinity to 1, you will take x plus 2 as a function. And between 1 to infinity, you take x minus 2 as a function. Clearer? So if whatever value at which x plus 2 is ending, if at the same value x minus 2 is starting, then it will become a continuous function. Are you able to understand what I'm trying to say? So x plus 2 is the one which is coming from left. So wherever x plus 2 is giving you a function value, x minus 2 is supposed to start from there. Shall we check and see? Right. For this kind of a problem, what are we supposed to do? You go with the left limit and right limit. Okay. Limit. I'm not looking at the solution. Limit extends to 1 minus. What will you write? F of x. So limit h tends to 0. F of 1 minus h. So what is this? Limit h tends to 0. 1 minus h. Now what am I supposed to do? Very good. 1 minus h plus 2. Substitute the limit. It will give you 3. What about right limit? Limit extends to 1 plus. What will it give? F of x. So limit extends to, h tends to 0. F of 1 plus h. 1 plus h minus 2. 3. Right limit in the function x minus 2. So minus 1 plus h. So limit h tends to 0. Answer will be minus 1. What about function value? Function value is f of 1 is what you will take. F of 1, which function should I take? First one or second one? First one. Answer will be 3. So left limit is equal to the function value. So it is a left continuous function. See that you will not write it in CBSE, it is for your knowledge. You need not write it as left continuous function. You will just say it is discontinuous at point x is equal to 1. That's it. Is it clear? So when the question is about discuss the continuity, you should either say the function is continuous or discontinuous. If it is discontinuous, you need to mention the point at which it is discontinuous. Generally, for these kind of problems, discontinuity will exist at the point where the function is broken. That is at 1. So are you guys able to understand the graph? Are you able to understand the graph? So 2x plus 3 in another. You know that y is equal to mx plus c, right? So y is equal to mx plus c is the where 3 is the y-intercept. So this is how the graph will look like. So it will get extended in this direction, but it is going to stop at this point. I need to put a closed circle because function value is existing at that point. Where will the open circle be? For the next graph at the bottom. So it is going to be like this. Sometimes they might. If your teacher expects it, it is better you know it. If not, I would suggest you to learn it graphically because this will help you in a chapter called Applications of Integrals. There you will be asked to draw the graph. So it's better you know it. Example 11. Try guys. Fast. So x less than 1 left limit. X equal to 1 function value. X greater than 1 right limit. Finished. Breathe. 1 minute. Yeah. No, just repeat. The book method. So they have done left limit and right limit. It's simple. Wherever the function is broken, no left limit, right limit, which is on. That's it. But you need to show those steps properly. I showed you, no, in the step circle, 1 plus f of x. Limit extends to 1 plus f of x. Limit h tends to 0 f of 1 plus h. You need to show those steps properly. Clear, guys? So is it continuous or discontinuous? Discontinuous. So generally, if you substitute the value itself, you will understand for polynomial. One limit will give you 3, one will give you -1, and the function value is 0. So it is neither left continuous nor right continuous. So that is why if you see the graph, there are 2 open circles. Correct? Do this. Discuss the continuity of the function defined by f of x is equal to x plus 2 if x is less than 0 minus x plus 2 if x is greater than 0. So even before you solve this question, can you tell me is it going to be continuous or not? Because they didn't give you what is the function value. Strictly less than 0, strictly greater than 0. Function value. So left limit and right limit might be the same, but function value, since we don't know, it is by default going to be discontinuous only. But show those steps. One minute, I made a mistake. I'm sorry. Since 0 is not a part of the domain, I forgot about it. 0 is not a part of the domain. So in whichever value they are given, the limit values are existing. So it is continuous. So what is the second definition telling us? You can say a given function is continuous if it is continuous in every part of its domain. So in this domain, in the given domain of the function, there is no zero at all. Like how we did for that 1 by x. 1 by x also didn't have zero. Correct? Huh? So this also I can say real number minus zero. This function is still a continuous function because I'm able to substitute 0 and c. Left limit is giving me 2. Right limit is also giving 2. Guys, are you able to understand what I'm trying to say? Akash Purida, right? So it is a continuous function. I'm correcting my statement. It is a continuous function in the domain of it. What about 13th one? Discuss the continuity of the function f of x is equal to x for x greater than or equal to 0, x square if x is less than 0. Continuous. So even before you solve, just substitute that and see. No? For x greater than 0, what is the function? X no. Substitute that 0 and see. 0. X equal to 0, 0. X less than 0, 0 square, 0. So it will be continuous. But by the continuous is equal to, don't make the mistake of not showing the steps. Because the same it is going to be subjective, they will expect those steps. So master them. So what are they asking in example number 14? If you take a polynomial function, they're asking us to prove that the polynomial function is continuous throughout its domain. What is the domain of a polynomial function? So all real numbers. Now what are we supposed to do? Consider an element C that belongs to R and then do it. So if like you can do the way they have done it, P of x and everything they have done it, no? That is one way. If at all you don't get that idea, then you can say P of x is equal to A naught x power n plus A1 x power n minus 1 plus so on till an. You can take something like this. You can take a general polynomial and then solve it. Even that is accepted. Okay. If you are able to understand the solution, well and good. If not, take a general expression and then solve. Purida. Yeah. So 15th one, what are they saying? Find all points of discontinuity of greatest integer function defined by f of x is equal to greatest integer of x, where greatest integer of x denotes a value less than or equal to x. So even before you solve, can you tell me where will it be discontinuous? At all integer points. Why is it so? Yes, because on the left of the given integer, it will be the number before that integer. On the right of the given integer, it will be the integer itself. For example, what are we trying to do? So let's say I have 0.9. It is on the left of 1. So when you're doing left limit, you will take 1 minus h. So what will be the value for this? 0. Whereas when you take the right limit, 1.1, 1. So left limit value is not equal to the right limit. Okay. But what about the function value? The function value will generally be equal to the right limit. What is f of 1? 1. So 1 is what? Right limit or left limit? Right. So for the greatest integer function, it looks something like this. I'll show you the steps that you're supposed to write. Okay. Please copy this. 14th or 15th? 15, right? So f of x is equal to greatest integer of x. Okay. So what is the domain for all values of x that belongs to? The function is defined. Whether it is continuous or not, that's a different story. Function is defined for all real numbers. Let C be an integer which belongs to R. Accepted. So limit extends to C minus f of x is equal to limit h tends to 0. What should I write? greatest integer of c minus h. Accepted, guys? So when I say c is an integer, c minus h will be a value which is less than that integer. So when it is less than the integer, what will be the output of a greatest integer function? C minus 1. Now. So this will become limit h tends to 0, c minus 1. Right. Since we don't have any h here, the answer will be c minus 1 only. Right. Similarly, limit x tends to c plus f of x. What is it? Limit h tends to 0, greatest integer of c plus h. So limit h tends to 0, c plus h is going to be c or c plus 1 now? C itself. Okay, this will give you c. What is f of c? It is greatest integer of c, that will give you c. Since the right limit is not equal, left limit and right limit are not equal, it's a discontinuous. So since they ask you to discuss the discontinuity, where is it discontinuous? At all integral points. At all integer points, it is going to be discontinuous. That's what I proved. No, I took c as an integer. Here I end. Right? So the next part is about algebra of continuous function. I'll just give you the introduction. Problems we'll do it in the next class. Okay. So algebra basically they talk about the basic operation: addition, subtraction, multiplication, and division. Okay. Suppose you have f and g to be two real valued functions at some real numbers. Okay. Then what you can do is, if f and g are individually continuous at the given point c, then if you try to calculate the value of f plus g, then that function will also be continuous at c. Similarly, if you have f minus g, that will also be continuous at x is equal to c. F into g will also be continuous at x is equal to c, and f by g will also be continuous at x is equal to c, provided g of c is a non-zero value because it is in the denominator. I'll give you a simple example. If I take x is equal to 0, okay, I have a function f of x is equal to x square. I have a function f of x is equal to sine x. Okay, so tell me if x square is a continuous function at x is equal to 0. You take left, right, and so you do whatever, you're going to get function value as 0. What about sine x? Yes, it is continuous. So if these two are individually continuous at the given point, then if there is a function h of x given as x square plus sine x, by default you can say that this is also a continuous function because the functions which are involved in the operation are individually continuous functions. That is the meaning of that statement. Okay, we'll be using this logic, and based on this, as I told you, we'll solve the problems in next class. Okay, apart from that, any doubts? Right? Okay, so tomorrow we'll complete continuity and go to differentiability also. The number of problems are more, I think 34 or 35 or but I remember I've solved every problem in Appler. So I'll solve few problems here, remaining things you can solve it at home. I've already given a detailed solution for everything. So yeah, you can have a look at it so that we can go to differentiability in that sense. Sorry. Guys, any doubt? Those who are online, any doubt?
No, sir.
Understood, sir.
Okay, yeah, we can wind up this.
Thank you, sir.
In the app.
Thank you, sir.
I have it in the app.